Hi everybody, Vigorous Rapscallion here, and looking around, you may realize that we're floating in space, and that's because today we're going to be doing zero-G navigation. We're going to go over two main ways to navigate through zero gravity today. One is by using kind of wrist rockets to move around, so I'll demonstrate those real quick. You just point where you want to go, and click the throttle. It works with both hands, and they give the same amount of impulse, so if you use both hands at once, you change velocity quicker. And we can grab onto objects, like so, move ourselves around relative to the object, and then kind of launch ourselves off the object towards something else. Just like that. It feels really good. It's a lot of fun to just kind of mess around and navigate like this. I love games with this type of mechanic. Star Shelter, Echo, both excellent. I just think that VR lends itself really well to zero-G and underwater stuff. It's a lot easier to think in 6 directions when you can see in 3 dimensions. So, yeah, I think it's a great choice for the medium. But without further ado, let's hop right in, and I'll show you how to set up these two mechanics. So, mainly because it's simpler, we're going to start with the throttle mechanic, those little wrist rockets we were just looking at. So, as I often do, we're going to start by making a copy of our VR pawn here. You can see I've already got a couple from when I was setting the video up. Let's call this VR 0G. Open that up, take a look. Whoops, forgot because I took pawn out of there. There it is. So this is going to be what we're working with today. We're going to leave most of this in here. The snap turn that's already set up here is super useful. We're kind of going to use that set tracking origin to floor, so let's not mess with that. But teleport we do want to take out. Because I have no floors and no navigation set up in this, it wouldn't change anything, but it would still allow the player to, you know, press the button and have that kind of broadcast out, which isn't going to make any sense, so let's get rid of it. Next, we're going to go over to viewport here, and we are going to add in a capsule. And that is because we're going to need to apply physics to all of this. And you can't really do that with a pawn. It's not set up to work that way. So we're just going to add a capsule in. I'm just going to leave it named capsule because it's going to be the only one we have. We won't need a more descriptive reference, really. And we want this to be the root. So go ahead and grab that and drag it on top of VR Origin. And that's going to make it the root for this actor. So any physics we apply to this capsule will be applied to the entire actor. Next, in our settings for the capsule, over here on the right, we're going to want to simulate physics, but we are not going to want to enable gravity. Obviously, that's the whole point of this setup, so we don't want gravity. Position, we want all 6 degrees of freedom, so we're going to leave all these open. Rotation, we don't want, say you bump into anything, a radial force will be applied. So this could kind of go up and down. Just to be safe, let's lock those because we have no reason to change them at any time. But Z we have to keep open, and that's if we want to keep the snap turn functionality. Otherwise, I have tried it out, I won't demonstrate it. But what ends up happening is it tries to reset the position kind of relative to where it would be after the rotation, but since it can't rotate, it just moves you either forward or to the right by like a little tick. So you want to leave that unlocked. However, that means if we run into something, this is going to start spinning, and if you've never experienced it, there is very little more nauseating than spinning without your control in virtual reality. You do not want that to happen. So what we can do here, we're going to need impulse later, so we also don't want to be messing with this at all. So what we can do instead is just go up here to angular damping and set that to 1000. That's pretty much just going to cancel out any forces that would get put into this angularly immediately. Next, we're going to go back into our main viewport here. And I already made these, and I left them kind of outside of any folders. So let's take a look at this. You need 2 new input actions. So to get those, go on up to Input, and input action. These are throttle left and throttle right. I made these in axis 1D. If you'd like, you can set it so that depending on how hard the player presses the button, it changes, how much velocity you're getting. I found it's better to just kind of have it as a binary, but in case you want to do it that way, we are going to set it up like that from the get-go. So make that an axis 1D, and then search up input, and you're going to be looking for IMC default. So I already added these in, but I'm going to get rid of one so you can see how to do this in case you're not familiar with it. So let's go ahead and delete throttle left. So throttle right's already set up. To set up throttle left, go up there to add a mapping, search up throttle left, and then we are going to choose, in my case, Oculus Touch left trigger axis. Of course, if you're using something besides the Oculus, you're not going to want to use Oculus, and if you're setting this up for other people to use it, you're going to want to go ahead and put all of them in there, like the stuff for the Vive. And just same deal here, left trigger axis. And you just set that up for every controller you might be working with, but I'm not going to do that because it's tedious. All right, close that up, make sure you save it, and then we're going to go back into our pawn. We're going to go back to the event graph, and first we're going to set up these two throttles. So let's start with throttle right. And we're going to want to go ahead and grab that motion controller right grip. And we're going to want to get the up vector. But then we're actually going to want the inverse of that. So go ahead and take that vector and multiply it by -1. Great. And then we're going to grab our capsule, add impulse, and we're going to take that multiplier and plug it in. And that's it. You just do that straight off triggered, so as long as you're holding that down, it's going to add a small amount of impulse every tick. I found that works pretty well straight out of the box. So then you just do the same thing with throttle left. Just going to grab all this, duplicate it, and the only thing we need to change is instead of motion controller right grip, we want motion controller left grip. Next, we need to make sure that we're working with the correct pawn here. So, to find your game mode, just here in content, type in game mode, and you should get VR game mode. Then go ahead and set your pawn to whatever you called it, in my case VR0G, compile, save, and that should be everything we need to start testing. Let's try it out. Okie dokie, let's give it a shot. Go ahead and press the throttle, and as you can see, we're moving whatever direction the hand is pointed in. Now, another way you could do this is you could go off where the player is looking. Some people feel like that's going to be, better for nausea. I think that you already have to have a pretty, high tolerance for VR to play any 0G games, so I don't feel like it's really necessary. Plus, the wrist rockets feel really cool. But if you did want to do that, you'd do the same thing where you set up that throttle button, then just instead of getting your forward vector from the hand, you would get it from the headset to make sure you're moving whatever direction the player is looking. As you can see right now, we can't grab those cubes. So let's go ahead and set those up next. And one minor thing I forgot, you are going to get just a sea of warnings here, because technically you shouldn't be adding impulse to that capsule the way we have collision set up right now. It's just going to give you a warning, it's not going to crash, but I don't like having warnings, so let's see how to fix that real quick. Go over to capsule. And then down here for collision presets, You can see we want query in physics. So let's just go ahead and make it a physics actor. And there you go. That should get rid of that warning. And once you've changed that to physics actor, you want to come back into the event graph here and change this add impulse to a velocity change. Now that it's a physics actor, it has mass, so velocity change will kind of negate that. So next we're going to set up these grab point cubes. You just want to make a new actor here, and then just grab any type of cube mesh. I ended up going with the chamfered cube and used water as the texture just because it looks neat. There's nothing special about that. Yours doesn't have to look like this. And then once you put it in the scene, you just make it a good size to grab onto. But we need a couple of things in here, not a lot. One thing we need is a reference to the motion controller, just a motion controller. We only need one. And you also need a vector. And go ahead and call those grabbing hand and grab location respectively. And that's all you need to have this set up. Okay, back in our pawn, we need to start setting up the grabbing logic. So let's go ahead and go up here and we'll start with grab left, since they're going to be mainly the same. Just go ahead and disconnect this and move it way, way over here, so you got plenty of room to set up some new stuff. But we're not going to delete this logic over here, because after we set this up, we also want to have it set up so that the player can still grab objects that are not classified as a grab point. Next, we're going to be setting up something that looks quite a bit like the try grab action, or a try grab function, if you remember looking at that in one of the earlier videos here. So off of started here, we're going to want a sphere overlap actors. Then for sphere position, this one's the left hand, so we're going to want to grab motion controller left grip, get world location, and plug that in for the sphere position. Let's go ahead and make it a little bigger than the default grab radius, which is 6. Let's make this one 10, just in case somebody's flying past something quickly. For object types here, go ahead and make an array, so drag out from object types and type in make array. And we want this to be looking for world dynamic. There we go. Then from this out actors, we're going to do a for each with break. For each loop with break. There we go. And we're looking for a grab point cube. So we're going to go ahead and drag out from array element and put in as grab point cube, or sorry, cast to grab point cube. And then we want to make sure it is a grab point cube, so that's going to be in the case that the cast was successful. We're not going to worry about cast failed right now, we're going to come back to that. So let's go ahead and promote grab point cube to a variable. That way we can just grab everything we need from it without having to get that actor and get the correct one again. Then we need to set those two variables we made before in any order. So that was grabbing hand. So we're going to go ahead and set grabbing hand. And then we're also going to want to set grab location. There we go. And for grabbing hand, since this is the left one, we want motion controller left grip. And then once again, we want to get world location from motion controller left grip, and that is going to be our initial grab location. Lastly, once this is all done, if we did find a grab point cube, we want to grab the first one and then break this this loop here. So go ahead and grab from the last part of this logic and bring that back to break. Then when we let go, well, first we only want anything to happen when we let go if there is a valid grab point cube. So let's go ahead and get the grab point cube, drag out an is valid. You're going to have to here a function or a question. You want the parameter, which I just clicked on the wrong one like an idiot. Alright, let's see here. It's valid. You want that one. Grab from completed into execute. And then in the case it is valid, what do we want to happen? We want to dereference all this. We want our grab location, grabbing hand, and grab point cube to all reset. So drag this out and set grabbing hand to null in the case it is valid. And then we want to take the grab point cube reference we have and also set that to null. And once again, to do that, you just don't plug anything into these nodes, and it will reset it. And just like we did for the throttle, we're going to grab all this and duplicate it. Let's Control D, move it down a little bit, move that back over. Whoops, didn't mean to double click that. Move that over. Grab our input action grab right. Break those connections. Plug in our started and completed, and then once again all we need to do is change our motion controller grip references. Where is right grip? There it is. And just plug those in everywhere that left grip was plugged in before. Simple as. So we need some things to happen. So let's go ahead and grab an event tick. There we go. And before we do anything here, we're going to need to see if our grab point cube is currently valid. So go ahead and grab that. Get yourself an is valid. And we'll check the execution off of that. Then we need two locations from this grab point cube. So let's do get grab location. Then get grabbing hand. And we want the location of the grabbing hand. Get world location there. Then we want to grab the difference between these two. So go ahead and get yourself subtract. Plug that in. Then we want our current actor location. Get actor location. We're going to add that value to this value. Plug that in. And then simply set our actor location to the result there. So that's basically going to get the difference between these two locations and reset the actor's position relative to that. So with that, we should be able to move around relative to our hand location when we're grabbing one of these objects. Let's try it out. So our throttles are still working, nothing broke there. We should be able to grab with either hand here. And there you go, look at that. Now we're moving relative to the hand's location. And let's see what happens when we let go. Well, there's our first problem. Let's try and demonstrate that again. You can see right before I grabbed, I was moving in that direction. And when I let go, I keep moving in that direction. And that's going to be a little bit of a problem, because if we're trying to add velocity based on the player pushing off, that's going to get mixed in with the velocity that they already had. And it's going to be really noticeable if they're going pretty quick, as you can see there. So let's fix that first. Luckily, it is a super simple fix. All we're going to do is go back into our event graph here, and in both of these functions, we don't want this to be happening if we didn't grab a grab point cube. So, in between here, you want to break this location, grab your connection, grab your capsule, set linear velocity, and we're just going to set that to 0, so you just leave it blank. And now whenever we grab onto one of these cubes, it's going to negate all of our velocity. Just do the same thing down here. Move that over, break the connection, and set that to 0. Let's see if that worked. Throttle over to one of these. Let's get moving pretty quick, actually, so you can really see it. You grab it, And boom. Now, whenever you let go, you have 0 velocity. It cancels out all the velocity you had there. Which is actually kind of an interesting mechanic on its own. I could definitely see like a puzzle game that utilizes this. But if we want this to feel like 0G, we want the character or the player to go flying when they do something like that. So let's fix that up next. So what we're going to do here, because I do want this next part to be fully physics-based, so we're going to need some kind of velocity reference. Now, the issue here is since we're setting actor location directly based off this interp here, there is no velocity. Technically speaking, the capsule is not moving. Its kind of relationship with the world is changing. And luckily, one thing I discovered from fixing up this the grabbing video, or sorry, the throwing mechanics video, so it would work for 5.4, was you can pretty much always get a velocity readout from your controllers. Regardless of what's attached to them, what they're attached to, you're always going to get something from those. So first we need a reference to those controllers, but of course that's going to be different depending on the grab point cube here. Luckily, we can just pull out get grabbing hand, and that's going to be the motion controller we want. Go ahead and pull out get linear velocity. And what are we going to set this to? Well, we're going to use a really similar setup to the one from my throwing mechanics video, where we're going to make an array to store some velocity information over the course of several ticks. Let's call this velocity folder. We're going to make that an array of vectors. Compile so that you can choose how many elements you have. And just like we did last time, we're going to make it 5 elements total, so indexes 0 through 4. Then we're going to need some integers. Let's call this velocity holder FC for flow control. Make that an integer and not an array, just a single integer. Next, we need to start setting these values, and we need to go up that array and then reset. So let's go ahead and grab that. Do set array element. Break that connection off of isValid, plug that in, plug in this out linear velocity. And then we need to grab our index here, our flow control, and plug that into index. Then we need to increment that integer until it gets to 4, and then we need it to restart. So let's get ourselves a less than here. And let's do less than 4, so once it's equal to 4, it will do something else, which is when we need it to reset. Drag out a branch from that. In the case that it's true, what do we want to happen? We want our integer to increment. And in the case that it's false, we want to reset that integer to zilcho. Grab both parts of that branch there and plug them into set actor location, so that's still happening every time. And now, just like with the throwing mechanics, we have that same functionality where we're getting a kind of rolling 5 values for that array. Now, what's going to happen when we let go? How are we going to get the information that we let go? Well, that's pretty easy. If we go down here and look at this, remember that this as grab point cube is going to be dereferenced when we release that grip button. So that is great. Let's go ahead and take a look here. So we've got this is valid here for grab point cube. Once we release and that's dereferenced, this is not valid is going to execute. But this is off event tick, so we don't want it to just do it all the time. So we're going to use a do once, and we are going to use the end of this function, which won't be reached until we grab another grab point cube as the reset. We're going to start closed, and then once it's completed, what do we need to happen? We need to add that impulse to this capsule. So let's grab our capsule. Don't know what happened there. And set linear velocity. And what do we want to set it to? We want to set it to the average of that array. So grab your velocity holder, get array average, and go ahead and plug that right in. And that should be just about it. Now, once we release that, we should be executing this line of code. We'll take that velocity holder information, average it, and set the linear velocity to the capsule. One more problem, which I could go in and demonstrate, but I'll just tell you about it. This is going to be the opposite of what we want, actually, because the direction of the hand is going to be the opposite of where the body is moving. So we actually want to invert this, which is very easy to do. You just multiply by -1. Change that to a float. And now we're going to be moving in the opposite direction that the hand was moving from, which should feel like it's sending the body flying off. Let's check it out, see if it works. So as usual, first we make sure that nothing broke here. Okay, throttles are still working. We can still grab, and let's try throwing ourselves. Look at that! Video flying off in the opposite direction of the hand. So let's do one where you can really see it. So say you want to push yourself backwards. Push off, and you go flying backwards. And this feels pretty good out of the box. You could definitely tweak this a little bit. If anything, it feels a little too fast right now. It's a little, unrealistically fast. So you could divide it, but I don't know. It feels fine and video gamey. But if you wanted a more realistic feel, you could definitely tamp that down, and you do that just by dividing that number. Now, the next problem, as I said, we still want to be able to grab stuff that's in the environment, and right now we can't because we got rid of all that functionality. So that's the last thing we're going to do in the video. Let's see how we can set it up so you can still grab stuff that's out in space with you and grab on to the environment. So this sounds like it's going to be kind of a complicated problem. I mean, how do you decide which one you're going to grab? It's a lot easier than it seems. Luckily for both of these chains of logic, we have this is valid, is not valid in some form. Here we have it as the for each loop, just if it never executed, you could go ahead and execute the next thing. So you just need to decide what order you want it to happen in. I think it makes a lot more sense to try and grab an object before you try and grab the environment. It's going to be frustrating for the player if, say, they're trying to grab something out in space and it's right next to a wall and it just keeps attaching to the wall. That's going to be super annoying, so we probably want to do object first. So, in the case that we didn't have an object, we need the next thing to execute, so we're just going to do that off this is not valid. So let's go back over Schmear, disconnect this, grab everything from that chain of logic, move it on over here, put it above it, and neaten this up a little bit. And then in the case this is not valid, we want to try this instead. Then, for the completed, it's even easier. For the completed, it does not matter what order this stuff happens in. Since it's just checking if it's either holding the environment or an object, it can happen in either order. So I decided to do it with environment first just because it's simpler. So just plug in that is not valid from the first part into the existing logic from before. And then same deal, take this started and plug it in right there. Then we just need to do the same thing for input action grab right. We're going to need to make some room here. We're getting pretty crowded, so it's a good thing that we deleted that teleport before. We got just enough room up there to do the same thing and move everything over. And started. Here we go. And that should be just about everything we need. Let's go ahead and test it out. Okay, So let's first see if we can grab objects at all now. Moving ponderously towards this cube. Oh, there we go. And sweet. We're able to grab it, able to get rid of it, throw it in 0G. That's kind of neat. I like that. That's fun to look at. Anyways, oh man, I wish I'd thought of that when I was making the throwing mechanics video. Showing how it worked in 0G would really show the vector a lot better. That would have been cool. Well, too late now. Next, let's make sure that we can still grab this stuff. And we can still launch off of it. And can we grab an object while anchored to the environment? We can. Look at that. And in a game like Star Shelter, if you've ever played that, where you have to kind of be holding on to things and picking stuff up, that's super useful. There is still one problem. Let's go ahead and release that. I just released it, which you can't see, but nothing is happening. And that's because I was still referenced to the grab point cube, so it's not going into that other line of logic. If you just go ahead and click the grip, it's going to redo that, but you're still going to get some strange behavior after that. Now, the video is already pretty long. I'll probably post a fixed video in a couple of days showing you how to do the last part of that logic there. But not to be all physics textbook, but for now, I leave it as an exercise to the reader. Some clues: you're basically going to need a boolean, you're going to need a reference to what hand is grabbing what, and you're going to need to make that logic a tiny bit more complicated and probably double it up and run it through after that boolean. See if you can figure it out on your own, but I'll have a hotfix video up in probably a day or two for that. As always, thank you for watching, and have a great day.